All right, now I'm going to flip to the back side of my worksheet onto number 6. On number 6, I'm not going to do this one with you, but I do want you to be aware that you need to calculate the volume again. When we're calculating that volume, we are doing length times width times height. So just a reminder there on that one. And then this one right here, the PVC number 7, you are taking that milliliter and you're just plugging it in. You're just changing the label there. Now, number 8 seems to be pretty tricky. Number 8 is fluid A, B, and C. I just need to change that there. And I am going to do mass divided by volume. Just like I have on the other side of my worksheet, I have density equals mass divided by volume. If I tend to forget that a lot, then I need to write it down so that I make sure that I'm doing the math correctly. So fluid A, I'm just going to start by doing this. Fluid A, density equals, I'm going to do mass over my volume, so 2,060 grams divided by 2,000 milliliters, and I will get 2060 divided by 2,000 equals 1.03. So fluid A's density is 1.03. Now I'm going to do the same thing for fluid B and fluid C. So fluid B, I'm going to calculate the density by taking the mass, which is 672 grams, divided by the volume, which is 850 milliliters, and I'm going to get 672 divided by 850 equals 0.79 and some more numbers after that. I want you to just round up to either the nearest hundredth or the nearest tenth. In this case, I'm going to round up to the nearest hundredth, which is 0.7, and since the number after that is a 9, I'm going to round up. So 0.8 grams per centimeter cubed. I'm going to plug that in over here for fluid B, 0.8, and then I'm going to do the same thing for fluid C, which is 990, that's my mass, divided by my volume, which is 1,100 milliliters, and I'm going to calculate that, which comes out to be 0.9. Now I'm going to take these fluids and I'm going to pretend that I'm pouring them into a beaker. I need to decide which liquid is going to sit the lowest, in the middle, and the highest in the beaker. I need to label each layer with fluid A, B, and C. So let's start with fluid A. It looks like fluid A is going to be the highest density. I see that here. So fluid A, higher density, means that it is going to sink. So 1.03 is my fluid A. Then I have to find the liquid that's going to sit on the top. The liquid that's going to sit on the top or float is going to be the lightest, the least density, or the least dense fluid. So it looks like fluid B is my least dense fluid, and then fluid C is going to sit right here in the middle because it is right in the middle there for density. Now on number 9, where I'm going to explain that, A says liquid blank is on the bottom because it is the what dense. Liquid A is on the bottom because it is the most dense. And liquid B is on the top because it is the least dense. Now, when I'm asked to define density, I am just looking for the definition. So you need to go back into your notes and look for the definition of density. Now I can flip that paper over, and I'm going to do this first problem with you, and then I will let you do the rest on your own. It says use your density skills to find the identity of the following mystery objects. So here's my table of densities. These are my objects, this is the density. These are my objects, this is the density. So there's 6 different objects and 6 different densities. Now, while digging, number 11, while digging in the backyard, you find an old coin. Its mass is 26.76 grams, and its volume is 3 centimeters. This should actually read 3 centimeters cubed because it's giving me my volume. That was a typo. What is its density? So I can simply plug in 26.76, it's a 2, and volume is centimeters cubed, so 3 centimeters cubed, and all I need to do is the mass divided by the volume. So I have 26.76 divided by 3, which equals 8.92. 8.92. Now, my next question says, using the coin's density and the table above, what is the coin made of? So I'm looking at the density right here, and I'm going to match it to one of these objects. It looks like the density matches perfectly with copper. So I know this coin is made of copper. Now you guys are going to go through the rest of these on your own as well. Make sure you're answering these little questions in between. Remember, volume is how much space an object takes up. So here, when it's asking for how much space did the ring take up, I just want to know what is its volume. So once you figure that out here, using that displacement method that we used before, you will then write the volume there and then plug it in to your equation. The rest of this is stuff we've already done on the other sides of the worksheet, so you can look back if you need some help on those.